Welcome to Math with Professor V. Here's your latest integral of the day. We have an indefinite integral of secant x cosine 2x over sine x plus secant x dx. If you want to pause the video and try it on your own, I'll give you a hint. You just need to rewrite the integrand by playing around with some trig identities and whatnot, and then just do one clean little u sub. All right. So to kick things off, what stood out to me was that we have these secant x's mixed in with sine x and cosine x. And the derivative of secant or its antiderivative doesn't involve sines and cosines, right? We know it involves tangents and, mixing up products that way. So I'm just going to say, secant, you need to be out of here, and rewrite it as 1 over cosine x. That's the first thing I thought of. So this is going to be 1 over cosine x times cosine 2x over sine x plus 1 over cosine x dx. And then at this step, I go, well, now I have a complex expression, right? Because we have a fraction inside of a fraction. Let's clear it out, clear out those extra denominators. So I'm going to multiply top and bottom by cosine x in order to do that. So in the numerator, this cosine x will just cancel out completely. Beautiful. So I'm just going to be left with, can you see what's left in the numerator? Just that cosine 2x. Okay, great. And then in the denominator, cosine x needs to distribute. So I'm going to have sine x cosine x plus 1. Yes? dx. Okay, good. Are we getting a little excited? Do we see where things are going? I'm looking here and I go, ooh, this is cosine 2x, and this reminds me so much of sine 2x, if only it had a 2 here. So, don't sit around feeling sorry for yourself. Make your dreams come true. I'm going to put a 2 out front. Of course, it would have to distribute, and then I need a 2 in the numerator as well. You can't just go willy-nilly multiplying by 2's. We can multiply by 1, though, anytime we want. So then now I have 2 cosine 2x over, yes, it distributes, okay, 2 sine x cosine x plus 2 dx. And I'm almost ready for that u sub. Let's just rewrite the denominator now so it's glaringly obvious. So 2 cosine 2x over sine 2x plus 2 dx. So can you see what we should let u equal? And my word of advice, you could let it just be sine 2x, but always throw in that constant as well. Because when you find du, the derivative of a constant is just 0. So then you're just going to have a simpler integral to evaluate in the end. So you should let u be sine 2x plus 2. Then let's take the derivative du. Derivative of sine 2x is cosine 2x. Don't forget the chain rule, times 2, right? Because of this 2 in front of the x, dx. And lo and behold, I have precisely that. That's 2 cosine 2x dx. Do you see it? Right here. Boom. So all of that is du. And then this denominator right here is u. So my integral becomes harmless little 1 over u du. Very nice. Okay, that one we know. Antiderivative is natural log absolute value of u plus c. And then let's go back, natural log absolute value, sine 2x plus 2 plus c. Now, I actually can drop the absolute value bars because we know sine of 2x, sine of theta, is always bounded by -1 and 1. So worst case scenario, the smallest this quantity can be is -1. -1 plus 2, that's not negative. And then if it's anything bigger, then for sure this is also going to stay not negative. No chance of it being 0. It would be 0 if sine 2x was -2. That's impossible. So I can just switch it and write my final answer, natural log sine 2x plus 2 plus c. And that's it. Good? How was that? I hope you enjoyed. Leave a comment down below. Tell me what your favorite part was. Tell me how you solved it. Maybe you did it differently. I'm curious to hear. Subscribe if you haven't already to my channel. I'm on summer break for a few weeks, so I'm going to be making a lot of new content, new uploads every single day. I put a new video out yesterday for differential equations. That's available for members only, but I'm also working on business calculus video lectures, algebra review for the calculus student. That's a whole new series that I'm going to be putting together, and lots of other good things, more advanced integration techniques to come. So stay tuned, turn those notifications on, and please follow me on Instagram, TikTok, Math with Professor V. I love you all. I'll be back sooner than later. Bye-bye.